Okay, today what we're going to do is we're going to go over ordinary annuities. And what an annuity is, it's a compound interest bearing account in which you make a regular deposit, the same amount each period, each month, each quarter, each year, whatever it is, okay? And that deposit is made at the end of the compounding period. And that part about it being at the end is very important because that's the difference between that and the annuity due, which we'll talk about in a few minutes. So the ordinary annuity is really a lot like our compound interest formula that we're already used to seeing. So it's this formula here. It's V, or the final value, is equal to R, the regular payment that you're going to be making, times 1 plus the interest rate, written as a decimal, divided by M, the number of times compounded per year, to the N, total number of times compounded. So remember, that would be M times T, minus 1, and all of that is going to be divided by the interest rate as a decimal again, divided by the number of times compounded. So this here is our formula that we want to use whenever we have an ordinary annuity. So let's take an example. So let's say our regular payment, let's go ahead and put away our, let's say $25, right? $25 isn't a lot of money to put away on a regular amount. Let's see if we can do that once a week. Okay, so $25 a week. And let's hope we get an interest rate of 4.8%, which would be pretty nice right now. That we would rewrite as 0.048 as a decimal. Okay. So then finally, let's see. So if we're going to put our $25 away a week, that's because we found a weekly compounding account. So let's go ahead and make M as weekly. And so how many weeks are there in a year? Right. There are 52 weeks in a year. You can look that up if you need to. That's a number to kind of know. 52 weeks in a year. And so let's see, how long are we going to put this in for? So let's do this for 10 years. So N is going to be the 10 years times the number of times compounded per year times the 52. So N is going to be 520 times it'll be compounded total over the life of the annuity. Okay, so we would go ahead and plug that in. It's going to go ahead and look like this. R is 25 times 1 plus 0.048, our interest rate, divided by 52, our compounding rate, to the 520 power, our number of times compounded over the life, minus 1. All of that's the numerator, and our denominator 0.048 divided by 52. Now, how are we going to do this in our calculator? Well, again, we're going to parenthesize the whole numerator divided by the denominator. So I realize the denominator is nice and small. We'll go ahead and plug that in there. 0.048 divided by 52. And then over here, again, looking at the order of operations, we have to do the parentheses first inside of the brackets. And in the parentheses, we're going to have to do division before addition. So let's see. So we're going to make sure we parenthesize 0.048 divided by 52. Then that we're going to have to add the 1 to it. We're going to have to group all of that before we raise that to the 520th power, right? And then all of that, we need to subtract 1, so parentheses again, minus 1. Then all of that needs to be multiplied by the 25. So let's choose one more color. There we go. So all of that times 25. So that's what I'm going to go ahead and put into my calculator. And when I do that, so let's see, parenthesis 25, paren, 1 plus, parenthesis 0.048 divided by 52, close, caret, 520, come down from that power and close that parenthesis, minus 1, close parenthesis, divided by parenthesis, 0.048 divided by 52. Close your parenthesis. Okay, so we get all of that, and we get 16,675.65898 dot dot dot. And recall, remember, because the bank is paying us, they're going to go ahead and truncate this. They're going to round down automatically, so that 8 doesn't matter. That gets chopped off. And here is our final amount. Okay, so our ordinary annuity, our $25 a week put away at 4.8% interest for 10 years turns into $16,675.65. So grows kind of quickly. Now, the ordinary annuity, the big difference here is right here at the end. So you put the money in at the end of the compounding period, then it gets compounded. Okay, not the whole time before. If we go ahead and take a look at the annuity due, the annuity due is simply an ordinary annuity into which the regular deposit is made at the beginning of the compounding period. Okay, so now as soon as you put it in, it compounds. So the only difference, this whole formula stays the same except for one thing. One little difference. Let me get rid of this guy right here really quick. And that's V equals R, our regular deposit, times 1 plus the rate divided by M to the N plus 1 power, because it's going to be compounded one more time. So we just add a 1 to it. So the rest of it's the same. Minus 1, close this off, put it here, divided by R over M. So we get the exact same thing. Now, do you think we would have more or less if everything else was the same for a regular ordinary annuity or an annuity due? With everything the same, which one do you think ends up with more money? Right, the annuity due, because this power is 1 larger. Everything else is the same. We do everything else. Notice right there, there it is. It's plus 1. That's the only difference. So because that's the only difference, that's going to make our other answer bigger. So what we're going to do is we're going to take this exact same answer that we had, all this work right here, all that work, and I'm just going to change this number right here, 520. I'm going to change it to 521. So I'm going to come back over here, and we're just going to put 521 in there. And on my calculator, I'm going to do second enter again so that I can just adjust it. And where it says 520, I'm going to change that to 521. And we end up with 16,716, oops, let me turn that over, 0.0519. Again, the 0.19 gets cut off, and we're left right there. $16,716. Now let's compare that. Notice, there it is. It's more, $675, $716. See, a little bit more. Now I want to back up over to this problem here, and I want to really quickly talk about finding the total of all deposits. So to kind of recognize how much you earned in interest in this problem. So if we put in $25 each week for 52 weeks for 10 years, what we've really done is we've put in $25 times 52, oops, being a little backwards there, times 52 weeks times the 10 years. And if we multiply that out, we end up realizing that we actually contributed $13,000 to that total. That is our total of deposits. Okay, so we put in $13,000. It turned into $16,675.65. So how much interest did it earn? Well, that's just a subtraction problem, right? We would take the total final amount minus the total of deposits, do a little subtraction there. We get our 65. What that's all going to be 675. Oops, one off, right? $3,675.65, and that would be the total interest earned. Okay, so that's just a subtraction problem there. Okay, so with those two things, I want to go ahead and stop there. We'll do another video to talk about the sinking fund, which is going in the other direction, knowing a target you'd like to get to. How much do you have to put away as your regular deposit if you include the interest with it? We'll get to that next. Alrighty.